Let's solve a problem related to heights and distances in trigonometry. So, there is a person standing on top of the hill and angles of depression of two consecutive kilometer stones are given, which is 30° and 45°. We need to find the height of the hill in kilometers, correct to two decimal places. So let's first draw the diagram. So, we have top of the hill, let's call this as hill. And from top of the hill, the angle of depressions are given. There are two angles of depression, one is 30° and one is 45°. So whenever there is angle of depression, first thing is remember to draw an horizontal line. This is the horizontal line. From this horizontal line till the angle, till the line of sight, it is 30°, and the second angle is 45 degrees. So there are 2 kilometer stones here. This is one stone and this is one stone. So there are 2 consecutive kilometer stones. So the distance is 1 kilometer. Because the distance between 2 kilometer stones is 1 kilometer. So let's call this triangle as A, B, C and D. And this distance CD is 1 kilometer. This is a right angle triangle. We'll have to find height of this hill. Let's call this as H. AB is H. Now using alternate angle principle, the first angle is 30°. So the alternate angle is this one, 30°. And the second angle is 45°. So alternate angle is 45°. Now let's call this, let's call BC as, say D1. Let's take the first triangle. The first triangle is, let's take it as tan 30. The first triangle, A, B and D. And this is H, right? And we know the distance here, C to D is 1 kilometer. Now using this, we'll arrive at tan 30. Tan 30 is opposite side by adjacent side. So what is the opposite side for this angle? It is AB. AB by adjacent side is BD. And what is AB? It is H. What is BD? BD is nothing but BC plus CD. And tan 30 is 1 by root 3. We know what CD is, right? H by, we don't know what BC is, but we know CD is 1 kilometer, this one. So we put as 1 here. So let's isolate H here. Let's put H on one side and shift everything else to the other side. So we get BC plus 1 by root 3. Let's call this as equation 1. Now let's go to the next step of finding tan 45°, which is for triangle ABC. This one. This triangle ABC is equal to opposite side is again AB, adjacent side is BC, right? It's this triangle A, B and C. This is 45°. This is H and we don't know what BC is. So AB is H. BC is, we don't know, right? And what is tan 45? Tan 45 is 1. So 1 is equal to H by BC. Let's isolate H. H is equal to, move BC on the other side, so it becomes BC into 1, which is BC. So let's call this as equation number 2. Now, from equation 1 and 2, H is going to be the same, right? Be it for this triangle or this triangle, height of the hill is not going to change. It's going to be the same. So, from equation 1 and 2, both are same. Equation 1 and 2 are equal, which means BC plus 1 by root 3 is equal to BC, right? So if you solve this, we are going to get BC plus 1 is equal to, let's take root 3 this side. So it's going to be root 3 into BC. So we'll take BC on the other side. We'll get root 3 BC minus BC is equal to 1. So if you take BC as common, you'll get root 3 minus 1 is equal to 1. So we will get BC is equal to 1 by root 3 minus 1. So let's rationalize because we cannot have root 3 in the denominator. So we'll have to rationalize. How do we rationalize? We'll have to multiply and divide by root 3 plus 1. So what do we get? We'll get root 3 plus 1. This is going to be 3 minus 1, which is root 3 plus 1 by 2. So root 3 is 1.72 plus 1 by 2, which is 2.72 by 2. We get 1.36 kilometer, which is the value of BC, that is this one. This is 1.36 kilometer. Now, from equation 2, height is nothing but is the same as BC, and BC we have got as 1.36. So height is equal to 1.36 kilometer.